Imagine this. An AI writes a complete piece of code in seconds that solves a complex problem and saves a tremendous amount of effort. Impressive, right? But now the question, would you also trust this AI to develop the software for a safety-critical medical system completely without humans? AI can already do amazing things in the field of software development today, but software engineering is something else entirely. And this difference is often overlooked, especially by executives, even though it is crucial in determining whether software ultimately really works, is secure, and can be maintained long term. So let's take a closer look. What can AI already do in the field of software development, and what can it still not do? My name is Tobias Löser and I'm a trainer and consultant for software engineering with a focus on architecture, quality, and agility. Why am I telling you this? Because these exact topics are the key when we talk about what AI can achieve in the context of software and where its limits lie. Because software development is not just typing lines of code, it's about systems that must be robust, maintainable, and secure. And that's exactly where the difference between software development and software engineering becomes apparent. When you hear the term software development in many teams or SMEs, everything is usually thrown into the same pot. Requirements, architecture, implementation, tests, and whether each area has its own roles or several are covered by one role doesn't really matter here. Some teams are simply small and some products are not particularly extensive either. But there's a crucial difference between software development and software engineering. Software development essentially means programming, so implementing requirements into code. This is where features, user interfaces, database queries, APIs, etc. are created. Software engineering, on the other hand, is much more comprehensive. According to the Software Engineering Body of Knowledge and the IEEE, it is the systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. This includes topics such as architecture decisions, which structures will best support the system over many years, quality assurance, from test strategies to code reviews, processes and methods that make collaboration efficient and agile, or requirements engineering, for example, eliciting, analyzing, and prioritizing requirements. The problem is, in practice, this difference is often ignored. People talk about development and mean everything by it. The consequence, important aspects such as architecture quality, requirements, or long-term maintainability are considered too late or not at all. Many software developers are actually software engineers and already take all important aspects into account. But when we talk about AI-supported software development, the question is, can AI also take on the task of a software engineer? Because that's what many executives already assume today, but without making a distinction between software development and software engineering. What can AI actually achieve in software development today? And where are the limits? Well-known tools like GitHub, Copilot, Cursor, or even Devin, which calls itself the AI software engineer, already impressively demonstrate what is possible. They generate code in real time. They write boilerplate code faster than many humans ever could. They even help with creating tests or documentation. There is a statistic on GitHub Copilot from 2025 that presents, among others, the following results. I quote, 55% faster task completion using predictive text. Quality improvements across 8 dimensions. For example, readability, error-free, maintainability. And 50% faster time to merge. However, the statistic is partly from GitHub itself. But these are already impressive numbers, and they are already changing the way many teams work today. But AI remains primarily a kind of pattern recognizer. It can combine existing solutions, complete code, and make suggestions based on what it has seen. For example, in many publicly accessible repositories. What it still can't really do is fully understand the consequences of architecture decisions, independently consider long-term maintainability and quality, translate business context and strategic company goals into code. In other words, AI is a powerful tool in development, but it does not take on responsibility for the entire engineering process. And that is exactly what is crucial when we talk about the future of software and software quality. One absolutely central area where AI reaches its limits, in my opinion, is requirements engineering. This is about eliciting requirements, analyzing them, setting priorities, and also resolving contradictions between stakeholders. That means negotiations, compromises, decisions that arise not just from data, but from human goals, values, and contexts. The same applies to software architecture. Architecture decisions are always a balancing act. Which technology do I use to ensure scalability and performance? How do I guarantee security and data protection? What trade-offs do I make between time to market and long-term maintainability? An AI can make suggestions here, but it has no overview over the company's strategic goals, legal frameworks, or team culture. And it is often precisely these factors that are more decisive than a single line of code. So if you want to develop systems that are truly successful in the long term, you cannot do without human software engineers, at least not yet. Another area where AI supports us but does not replace us is software quality. Because quality means more than error-free code. It's about robustness. How does the system react under load or in case of error? Testability, how easily can individual parts be checked and secured? Usability, how do real users experience the software? Compliance, are legal and regulatory requirements met? These are dimensions that do not automatically flow into the code that an AI generates. They must be consciously planned, reviewed, and continuously improved. And then there's another factor that AI cannot replace: agility. Agile methods thrive on communication, team culture, feedback loops with stakeholders. Scrum, Kanban, or extreme programming do not work because someone types code faster, but because teams collaborate better, learn, and adapt to changes. This is exactly where it becomes clear. Software, quality, and agility are deeply human disciplines. AI can provide us with tools, but the responsibility for collaboration, culture, and sustainable quality remains with us. A quick note at this point: if you would like to further develop your team or your company in precisely these areas, software quality, architecture, or agile methods, I'd be happy to support you with training or consulting. Feel free to get in touch. And if you found the topic exciting, feel free to follow me. I don't mind likes and nice comments either. This way, you stay up to date and can also share your opinion on the topic. Feel free to let me know which AI tools you have already tried, which ones you can recommend, and which ones you would advise against. Let's summarize again. AI can already do a lot in the area of software development today. It writes code, supports testing, saves time. But software engineering is more than that. It's about architecture, quality, requirements, collaboration, and responsibility. And this is exactly where it becomes clear AI is a powerful tool, but it does not replace the expertise and judgment of software engineers. The exciting question for the future is therefore not, will AI soon replace developers, but rather, how can we meaningfully integrate AI into our processes without neglecting the principles of software engineering? Because in the end, one thing holds true: AI can write code, but the responsibility for good software lies with us humans.